Hello and welcome to another Algebra 2 lesson by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 2, Lesson 6 on key features of functions. So there's many things that we want to talk about in terms of features that functions have, and we want to be comfortable with all of this terminology before we really get into the nitty-gritty of Algebra 2 and start looking at different types of functions like linear and quadratic and trigonometric and things like that. So let's jump right into it and discuss these major features. Now, functions have many important features, and most of these features relate to what the outputs, the y values, are, or how they're behaving. Many of these features are readily observable in the functions graph. So let's take a look at a function illustrated by a graph right from the beginning. All right, exercise 1. A function f of x is shown graphed below. Answer the following questions based on the graph. Letter A. What is f of 0? What name do we give to this feature on the graph? All right, well, why don't you go ahead and tell me the value of f of 0 and then see if you can remember what the name is that we give that feature. It should be pretty easy. All right, here we go. Well, f of 0, right, we have to come to x equals 0. It's going to be right there. So because the point 0, 2 lies on the graph, f of 0 is equal to 2. All right, and we call that the y-intercept. If a function has a y-intercept, and not all functions have to have a y-intercept, but if a function has a y-intercept, there is one and only one. Let's take a look at letter B. State the x-intercepts of the function. What is the alternative name that we give the x-intercepts? All right, well, the y-intercept is the one and only location where the function crosses the y-axis. X-intercepts are x values, and there can be more than one of them, where the function crosses the x-axis. So this should be pretty easy. Go ahead and write down the x-intercepts, okay? And then we will talk about what that alternative name is that we give the x-intercepts. All right. Let's take a look. Maybe I'll do these in red just so that they stand out a little bit better. There's an x-intercept right there. There's an x-intercept right there. And their coordinates are -6, 0 and 4, 0. I'm going to go back to blue now. Now, we're not going to include the 0. We just want x is equal to -6 and x is equal to 4. Those are my x-intercepts. But when you look at the coordinate pairs that go along with x-intercepts, it gives you a sense for what the alternative name is. Specifically, they are the zeros of the function, right? And they're the zeros of the function because they are the values of the input that result in an output equal to 0. Okay, let's keep going. Letter C. Over the interval x greater than -1, less than 2, is f of x increasing or decreasing? How can you tell? All right, well, take a look at the graph and tell me whether the function is increasing or decreasing over the interval x equals -1 to x equals 2. Well, again, let's go to x equals -1. Let's put a little point on the graph, and let's go to x equals 2 and put a point on the graph. Now, we always want to think about whether a function is increasing or decreasing by reading the graph from left to right. And the reason that we do that is if we're reading a graph from left to right, we are allowing the input to be increasing. So when we say, is the function increasing or decreasing, we're asking that really with this sort of parentheses, as the input increases. We never say that, but that's sort of implied. So if we're moving on this graph from left to right, then what happens is that the function is increasing, right? So go back to blue. It's increasing because the y values are going up as x increases. I don't really need a dash there. All right, the y values are going up as x increases. As we read this graph from left to right, the y values increase. Now, of course, you could say, well, the y values are increasing, then decreasing, then increasing, then decreasing, and then just a little bit of increase here at the end, right? So the y values are going from increasing to decreasing to increasing to decreasing quite often on this. Let's take a look at letter D. Give the interval over which f of x is greater than 0. What is a quick way of seeing this visually? All right, now, very, very important. Over which f of x is greater than 0. F of x is just a fancy way of saying y. All right, we want to know the interval, and again, this is important, even though they're not going to write it, what we're really saying is, hey, for what x values is y greater than 0? Now, of course, that's not the way it's going to be phrased. It's going to be a little more confusing. But over what x values is y greater than 0? See if you can write something down for that. Well, y is going to be greater than 0 everywhere up here. So what is that cutoff? Well, right here at x equals -6 and right here at x equals 4, that's where the function's equal to 0. So we can say x is greater than 6 and less than 4. Or if you like interval notation, you can do it like that. Now, as an aside, I cannot include the -6 nor the 4 because that's where the function is equal to 0. And if the question had said, give the interval over which f of x is greater than or equal to 0, well then I would have to include the equal sign here or here, here and there, sorry, or I'd have to put the square brackets on the end of that interval notation. Okay, let's keep going. Letter E. State all the x coordinates of the relative maximums and relative minimums, label each. Okay, so relative maximums and relative minimums are basically the tops and the bottoms of the hills that you see. Or, better yet, they're wherever the function changes from being increasing to decreasing or decreasing to increasing. So here we've got this function that's increasing all the way to x equals 4 and then decreases after that. And then we'll get to that one in a second. So at x equals -4, we have a relative maximum. Okay? Then we start to decrease from x equals -4 to x equals -1. And then at x equals -1, we change, the function changes from decreasing to increasing. And therefore, x equals -1 is a relative minimum. Okay. There's two more. Why don't you pause the video now and write them down and label what they are. All right, so from -1 all the way up to x equals 2, we're increasing, and then we change direction and we start to decrease again. So x equals 2 is the location of a relative max. And then we go from x equals 2, where we're decreasing, all the way to x equals 5, where we change direction and start to increase again. So x equals 5 is the location of a relative min. Okay, so let's take a look and keep going. What do we have in letter F? I don't know, a bug on the screen, it's okay. We got all the bugs out. It may come back. It might be a little visitor there. Let's take a look at F. What are the absolute maximum and minimum values of the function? Where do they occur? So relative maximums and minimums are simply sort of the little tops and bottoms of hills that functions have as we move along. All right. But the absolute maximum and absolute minimum values of the function are simply the largest y value and the smallest y value. So what I'd like you to do is literally put down y minimum equals blank at x equals blank, and y maximum equals blank at x equals blank. So see if you can fill those blanks in. All right, well, again, it's pretty easy to see that the lowest y value actually occurs right here, and that's at a y value of -4, right? It occurs at x equals -8. So y min is equal to -4 at x equals -8. Now our maximum, our absolute maximum value occurs here at y equals +8, okay, at an x value of 2. So y max equals +8 at an x value of 2. All right, great. So let's take a look at one last little piece. Well, all right, two last little pieces of this problem. Letter G. State the domain and range of f of x using interval notation. All right, we get to use interval notation, which is again awesome, and it's really easy. Remember, domain are the x values, range are the y values. See if you can write them down in interval notation. All right, well, the smallest x value is -8, the largest x value is 6, so our domain is going to be -8 to 6. I use square brackets because both the -8 and the 6 are included. And the range now, that's pretty easy because we can look back at our minimum and our maximum values. Our range goes from y equals -4 to y equals 8. Again, closed brackets because those two values actually occur on the graph. All right, now the final piece, letter H. If a second function g of x is defined by the formula g of x equals 1/2 of f of x plus 2, then what is the y-intercept of g? Awesome. I'd like you to see if you can figure this out. Keep in mind that the key to this always is that the y-intercept of any function is its output when its input is x equals 0. All right, well, let's just use the formula, right? We need to figure out what g of 0 is. And g of 0, by definition, is 1/2 of f of 0 plus 2. So g of 0 is going to be 1/2 of f of 2. We know that f of 2 is up here at 8, so g of 0 is 1/2 times 8, and that's equal to 4. So even though I don't really know what the graph of g of x looks like, what I do know is that its y-intercept is equal to 4. And granted, later on in this course, we're going to look at how we can look at a formula like this and interpret it in terms of transformations of the function f in order to get the function g. But we can certainly figure out what its y-intercept is at this point. All right, let's work some more with these types of features. Exercise number 2. Consider the function g of x equals 2 times the absolute value of x minus 1 minus 8 defined over the domain -4 is less than or equal to x is less than or equal to 7. Letter A, graph the function on the grid to your right. Show a table of values you use to create your graph below. All right, awesome. Now, we're going to go through this a little bit on the graphing calculator, but I want you to keep in mind that when they give us a domain interval like -4 is less than or equal to x less than or equal to 7, I want to make sure that my graph starts at x equals -4 and ends at x equals 7. There shouldn't be any like random arrows going up forever. Now, of course, you've graphed functions extensively on the graphing calculator. Let me just bring this thing out for a minute. I'm going to open up a new document. All right, nope. I want to add a graph. And of course, what I want to do in f of x, 1, is I just want to put this in. So I'm going to put in 2 times the absolute value of x minus 1. and then minus 8. Now, of course, when I do that, what it's going to show me is a picture of the function sort of for all values of x. What I really need, because I'm putting a graph on a piece of grid paper, is I need a table of values. To do that, right, we can hit the menu button, we can go back down to option 7, table, and we can put in a split screen table. Now it said to put in, to graph it from x equals -4 all the way to x equals 7. So I just want to create a table of values, -4, -2, -3, -0, -2, -2, etc., right? So what I'd like you to do right now is pause the video, create your table. Based on your table, then create your graph. And of course, your graph should look something like this, but it should start at x equals -4 and stop at x equals 7. So take a couple minutes to do that. All right, well, let me put this thing away for the time being. I'm going to go back into here. I just kind of created that table automatically. All right, these are the values that we should have written down. Once we plot all of these points and kind of plot them the way that we want them, we'll end up having that graph. All right, so simple enough. Now, let's take a look at letter B. State the domain interval where this function is decreasing. All right, so we want the domain interval where this function is decreasing. Now, keep in mind, right, we want to start at x equals -4, and we want to read this graph going from left to right. Clearly, right from the beginning, it starts to decrease and continues to decrease all the way down to here before it starts to increase again. So it starts at -4 and decreases all the way to x equals 1 before it changes direction. Now, my claim is that you can actually say that this is decreasing over two different intervals. You can say -4 is less than x, which is less than 1. Or, and I know I'm going to have a lot of math teachers angry at me for this, you can also include the endpoints. So -4 is less than or equal to x, less than or equal to 1. I promise you, if you are in New York State, and you had a Regents problem that asked this question, they would take either this answer, or they would take that answer, or they'd take one that was mixed up. You could have like an equality here and not one here, or vice versa. And we're not going to get into the nitty-gritty of why you can have the endpoints or not have the endpoints, because the bigger picture here is simply that the graph is going down from x equals -4 to x equals 1. Whether the -4 and the 1 are included or not is kind of like asking, is the top and the bottom of the hill included in the hill or not included in the hill, right? Anyway, let's keep going. So let's get that graph back out. Excellent. Letter C. State the zeros of the function on this interval. Awesome. Well, we've already talked about zeros of a function. We talked about how the fact that they are simply another name for the function's x-intercepts. So why don't you go ahead and pause the video and write down what the zeros are. All right, well, the zeros, let me mark them in red. So they're very, very obvious. There's a 0, there's a 0, right? Places where the output is equal to 0. And those are going to be at x equals -3 and x equals 5. Simple enough. Now, letter D asks us to state the interval over which g of x is less than or equal to 0. State the interval over which g of x is less than or equal to 0. And again, don't forget that what we're really asking is, what are the x values for which the y value is less than or equal to 0? See if you can write this down. You could use interval notation or set builder notation, either way. All right. So we're always less than 0 for a function if we are below the x-axis, right? And now it says below or sort of equal to 0, in which case, using interval notation, that's going to be everywhere from -3 to 5, including the -3 and the 5. Or if you prefer this notation, it would be completely okay to also write that down. All right, let's keep going. Letter E. Evaluate g of 0 by using the algebraic definition of the function. What point does this correspond to on the graph? All right, why don't you go ahead and evaluate g of 0 and then tell me what point it corresponds to on the graph. All right, let's do it. Simple enough, right? G of 0, we want to do this just so that we get some practice with absolute value. G of 0 is 2 times the absolute value of 0 minus 1. All right, so that's going to be g of 0 is equal to 2 times the absolute value of negative 1 minus 8. That's going to be 2 times 1 minus 8. That's going to be 2 minus 8, and that's negative 6. So g of 0 is equal to negative 6, and as always, whenever the input is equal to 0, what we're talking about is the y-intercept. So what point does that correspond to? The y-intercept of the function. All right, final piece on this problem, letter F. Are there any relative maximums or minimums on the graph? If so, which and what are their coordinates? All right, why don't you go ahead and answer this? Well, we only have one, and relative maximums and minimums are also known as turning points. So we've got that point down at 1 comma negative 8, and that is a minimum. So we're going to say a relative minimum at the point 1 comma negative 8. And that's it. Excellent. Let's take a look at one more problem. Here we go. Finding features in tables. You need to be able to work with functions in all their forms, including equations, which we've done, graphs, and tables. Tables can be quick to use, but sometimes hard to understand because you don't get to see the full picture. You just get to see these sort of isolated values, if you will. So let's take a look at exercise number 3. A continuous function f of x has a domain of negative 6 less than or equal to x less than or equal to 13 with selected values shown below. The function has exactly 2 zeros and exactly 2 turning points, one at 3 comma negative 4 and one at 9 comma 3. All right, now before we move on and we talk about this problem, just a little bit of a side note on the word continuous function. A continuous function is a function that can be drawn without lifting up your pen and your pencil, or your pencil. So in other words, if I had a function that looked like that, that would be a continuous function. On the other hand, if I had something that looked like this, that might be a function, but it's not continuous because I have to lift my pen or pencil up in order to draw the function. So a continuous function is one that doesn't have any holes in it, no gaps, it doesn't skip anything. It's nice and continuous from one endpoint of the function to the other endpoint of the function. All right, let's take a look at letter A. State the interval over which f of x is less than 0. Okay? Well, I want you to think about this a little bit. Where would the function be below the x-axis, right? The function is less than 0. See if you can write something down for that. Well, certainly the function is definitely less than 0 everywhere in here, right? But I wouldn't want to say that the function is less than 0 from 0 to 5. And here's why. We have a 0 at x equals negative 1, and we have a 0 at x equals 8. So the function is actually below the x-axis for all values of x that are between negative 1 and 8, but just not at negative 1 and 8, because that's where it's equal to 0. So I could either say negative 1 is less than x less than 8, or if I like interval notation, negative 1 to 8. You cannot say 0 to 5 because between x equals negative 1 and x equals 0, that function's going to be below the x-axis. Same thing between 5 and 8, that function's going to be below the x-axis. Now let's take a look at letter B. State the interval over which f of x is increasing. Pause the video now and see if you can figure this one out. Okay, well, the key here is knowing that we have two turning points and only two turning points. See, if we didn't know that we had two and only two turning points, we would be in trouble, right? But we've got one turning point here and we've got one turning point here. And I want to know where the function is increasing. Now, it should be clear that if I look at the y values, I go from -4 to -1 to 0 to 3. So the function is increasing all along in here. I know that it couldn't increase and decrease somewhere in here because if it did, there would be a turning point. All right? In here, it's decreasing all the way, and then here, after this, it decreases again. So where is the function increasing? Well, again, you can say this in two different ways. You could either say 3 is less than x is less than 9, or if you wanted to include the endpoints, you could. Please, no angry emails. Either one of these things would be acceptable. All right, let's take a look at the last piece of this problem. Real simple, one more time. You're probably sick of this question. Letter C. What is this function's y-intercept? All right, well, it'd be pretty easy to do the x-intercepts or the y-intercept. Why don't you go ahead and write down the answer? The y-intercept is the output of the function when the input is x equals 0. Here is that point, so the y-intercept is equal to -2. Always, 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 f of 0, g of 0, what have you. All right, when the input is 0, whatever the output is the y-intercept. Okay, let's summarize. There's a lot of different features that we looked at today in terms of a function. We looked at things like, where's the function increasing? Where's the function decreasing? What is the function's y-intercept? What is the function's x-intercept or x-intercepts? Another name for those are the function's zeros. Where is the function greater than 0? Where is it less than 0? Where does it have relative maximums and minimums? Another name for those are turning points. What are the absolute maximum value of the function and minimum value of the function? All these are very, very important features of functions that we're going to see come up with a variety of different function types as we move through this course. For now, I just want to thank you for joining me for another Algebra 2 lesson by eMath Instruction. My name is Kirk Weiler, and until I see you again, keep thinking and keep solving problems.